All right. Hey, everyone. My name is Rebecca. I'm a software developer engineer here in St. Louis. I've been doing tech for not quite 15 years, just about, and done a whole lot of different stuff from network security, firewalls, all the way up through DevOps. Done a little bit of stuff that touches the web, and one of the technologies that I really love working with and really love talking about is a language called Haskell. Some of you may have heard of it. Some of you maybe haven't. Just kind of curious, show of hands, how many people know much about Haskell at all other than that it's maybe a language? Awesome. So you all get to learn a whole bunch today. So what I wanted to talk to you all about today is how to build a backend web service using a particular Haskell framework called servants. And what we're going to do, I don't have any slides, but what we're going to do is we're going to live code together a to-do list application. So I think what I'd like from all of you is, as we're working through this, please just shout out ideas, shout out questions. We're going to go through and do this, and if we get through the application and still have a little bit of time left, we'll dig into some of the stuff that goes into the template that we're using, and you can dive down a little bit more into how things are working kind of under the covers. So I'm using Emacs here, and we'll be using this for the talk. If you're interested in Haskell and you've never used it, you come out of this talk and you say, hey, I really want to play around with that. Most of the major sort of text editors and IDEs have Haskell mode. So I know Visual Studio Code has a pretty well-respected one. Vim and Emacs, and I'm sure most anything else will have some degree of support. What we're going to do, so I'm going to go into my projects directory, and we're going to start by just creating a brand new project. And I'm using a tool called Stack. And in the Haskell world, there are a couple of different ways that we can build and manage our applications. So the sort of Haskell native way of managing applications is called Cabal. And Cabal is really good. It has a lot of nice features, but Stack is I don't want to say alternative. It's a tool that's built on top of Cabal, and it gives us some nice things, like it will automatically manage the version of Haskell that we're using per project. And it also helps make sure that all of our dependencies are going to work well together by providing long-term support releases. So we're going to use the latest release, and we're going to use Stack to create a new project. So I'm going to say Stack New. And let's just call this To-Do Server. And what I'm going to do is I'm going to start by giving it a template. So if we look at this Rebecca Skinner servant echo, I'm going to go over here, and I'm going to make this text much bigger. So I'm going to go to my GitHub page here, and you can see I have this directory called Stack, or this repository called Stack Templates. And inside of this repository, I have a file called servantecho.hs files. And so that's what Stack's using. There's no magic here. I've just defined a template. So if you think about something like Rails, for example, when you say like Rails new, it's very opinionated. It says, okay, I'm going to build you this whole project from scratch, and it's going to be a Rails project. Well, Stack's kind of doing the same thing, except it's saying that it has no opinions. You point it at the kind of project that you want. So you give it somebody else's opinions, or in this case, my own opinions. And it's going to generate a project for you. So I'm going to go ahead and, I was testing this before I gave the talk, so what am I doing here? Removing the wrong thing, that's what I did. All right, so I ran that command. Sorry, the errors where I already had that directory and then I deleted not that directory. That's fine. So when I say stack new, you can see that it's going to download my template and it creates a directory for me. So I'm going to go into my to-do server and I have a bunch of stuff here. I have a license file, a README, everything that I need. So we can go ahead and use stack build, and we're just going to compile this application. And this is just an echo server. It's not really doing much of anything, but it shows that we have everything set up that we need. We have the compiler, everything's built. So let's look at this directory that it gave us. We have a couple of things. Stack.yaml and stack.yaml.lock. Don't worry about that. That's just from our tool. But we have a couple of directories here. An app, a source, and a test. So what do you think we should look in? Let's take a look at app and source. So our app directory, we just have a single file. It's main.hs. And we have a bunch of files over here in source. So I don't know about you all, but main, that seems like a good starting point, right? All right, so our main is like nothing. So this is an interesting pattern that you'll see a lot with Haskell applications is inside of this app directory, you'll have a single file called main that has a main function, and all it's doing is calling library.start or library.libmain or some variation of that. The reason that we do this, that you'll see this pattern, is that when we write tests, unit tests in Haskell, it's a binary that's doing our test, and so we link our application as a dependency into our test program. And so we want to have as much functionality as we can in the shared library so that we can test all of it. So we want our sort of untested code to be as little as possible, which in this case is just a single function call. Is there anybody that would like me to talk a little bit more about this before we move on? Yep.
In order to get started, you typed in like stack new and a couple other things, and
Yep.
I missed that portion because I was trying to get it installed. What was that command?
Yep. So I'll bring it right back up here. So it's stack new, and then to do server is the name of our application. And then the second thing here is the name of the template that we're using.
And it'll just recognize Rebecca Skinner.
Yep, because it's going to go to GitHub and find Rebecca Skinner on GitHub, and then it's going to look for a repository called stack templates. And inside of that repository, it's going to look for a file called servant echo. Yep.
I was going to ask, how does Stack know that it should be looking for the repo in GitHub?
It's just opinionated. That's where it thinks things should go.
Was this Stack's original the default configuration, or?
Yeah, so this is actually a new feature of Stack. It used to be that they had a specific repository on GitHub that all of the templates had to go into, and if you wanted to make a new template, you had to create a pull request against their directory. And in more recent releases now, they've changed that so that it just looks on GitHub for your username / the template.
So I'm trying to make because I'm more familiar with Node and NPM. I see that there is some parallels here, like Stack is like NPM in a way that we also got a package, actually a JSON function block.
Right.
And then I guess like this Stack is functions similar like
Yeah, I think that's a pretty good analogy.
The stack is like NPM.
Yep. So, sorry, I guess I should repeat that for the people on video. The question, is stack like NPM? The answer is yes, that is a pretty good analogy. So we have all this stuff in source, and lib is the entry point. There's a whole bunch of stuff that we're not actually going to look at here, because this is just coming to us for free from this template that we generated. But what we're going to do is we're going to start by looking at, at our server. Because this is where we're actually defining what a server looks like, and this is where we get a chance to see what's really interesting about Servant in particular, which is that we're defining an API right here, and you can see, so our type API, we have two endpoints that we're getting for free out of our application. One is echo, and the other is just a default get, like, you know, a root route, I guess. So the way Servant works is we actually define an API as a data type. So all of our endpoints and everything that they take are data point, or are part of this API, the strongly typed API. And so what that means is, if, for example, let's say I delete this show root function here, and I go to rerun my program, I actually get a compile error. Like, I can't even build this if I would have a broken link in my application, because it's able to statically analyze and see, like, hey, you're telling me that there's an endpoint here that needs this functionality, but you're not actually giving me that functionality. And at the same time, like, if I changed this to say my show root's going to return an integer, and I try to build it, I'm going to get the same thing. I'm going to say, hey, the contract for my API is saying that I'm going to get back a string, but this function is giving me back an integer, so I can't actually define this API that you're telling me to define based on the way that you've implemented it inside of your code. So this is really the powerful part of Servant, but it's also kind of complicated to understand how it's working. So what we're going to do is we're going to change this to make it a to-do list application. And the first thing that we want to do is we see that we have this echo request, right? So I'm going to say, I'm going to use my fact that I wrote this template to know where to poke, but otherwise you might start using grep. I'm going to look at requests. So this is where I can define any of the requests that I want to handle in my server. And just like the API itself, we're defining these as data types. And so you can see right now that an echo request is just something that contains some echo data, which is just some text. So if you want me to echo something, you give me some text, I'll give you an echo request back. So let's make a request for a to-do item. So I'm going to say data, and that's how I'm defining a new data type. And I'm going to give a name to my data type, which is a to-do item, because that's what I think the fundamental unit of a to-do list is going to be, right? It's going to be some specific item in a to-do list. And I'm going to say to-do item again, because this is how I'm going to actually create a value. So the thing on the left and right-hand side here, even though I'm using to-do item for both of them, they're actually different things. This is a type, and this is a function that's giving me, this is a constructor basically. It's a function that's giving me that type back. So I could call this foo, and that would work just fine, except for it would be really confusing to anybody that was reading the source code and wanted to know what a foo actually was. So we're going to say this is a to-do item, and I'm going to give it a new line and put these in braces. So what do you think the first thing that we should have for a to-do item should be?
ID?
You think we need an ID?
Not sure.
All right, let's let's put one in there for now. What is an ID?
They use value.
Yeah, but what is an ID?
Like just type.
Yeah, what
I mean, you could use an integer and
All right,
or
let's call it an integer for now, because in Haskell it's a strongly typed language. Everything that we're working with has to have a type. We don't have the option of falling back and saying it's anything. We have to give it a concrete data type, and that's actually a lie. And you'll see here in a little bit why that's a lie. But for now, just go with it. Okay, so we have an ID. What else do we need? A name. Let's call it a title. All right. So we're going to make this a text. The reason that we're doing this, because the title's some string data, and we do have a string type, but string types in Haskell it's literally a linked list of individual characters, which is horrendously inefficient. So in the real world, we're going to use text for things where we might want to use a string. And you see it's a text.text. The reason is when I'm importing the text library up here, I'm importing it qualified. So by default, if I just said import text, I would get everything that's in the text library. But it turns out that all those functions kind of collide with things that are in the standard library. So I really want to put them behind a namespace. So that's why we tend to import a lot of the stuff qualified. So I'm going to say that in addition to a title, I want a description, because I want more than just a short blurb about what my item. Yep.
Would you say that qualified is just kind of standard for importing across the board in Haskell, or?
So different people have different opinions about it, and we'll look at a couple of other ways of doing it throughout this exercise. But I would say it's a good first place to go unless you have a reason not to. And so the last thing that I think we probably want is some sort of flag to say whether it's done. So let's make that a bool. So we have a to-do list. You can probably tell from the template down here that there's a couple of things that we probably want to do. So the first thing that I want to do is I'm going to load this up into a REPL. So all of you, is everyone familiar with what a REPL is? So it stands for read, evaluate, print, loop. And it's similar to like the JavaScript console. If you've used that in your browser, it just lets you type some code in and see what it's going to do. So, we can type in 1 + 1, and we get back 2. But since we loaded this, I can actually make a to-do item. So I can say, let item equal to-do item. And I'm just going to say my task is finish my talk. And the description is make it really good. Oh, I need an ID. Let's say it's the first one, and it's not complete. So I can pass things around. I could also say like ID equals 0 and title equals, I can parameterize them, but for the sake of fitting everything on the screen nicely, I'm not gonna. So that works, but if I say item, oh no, I can't actually print one of these out. That's terrible. I need a way to convert it to a string so I can see what it is, because debugging is important. Luckily, Haskell gives us this nice capability called deriving. And what deriving does is it says there's some interface. In this case in Haskell, we call it show, is the interface that's like things we can make be strings. And instead of having to write this for every single one of our types, we can just let the compiler figure out what it should look like. and give one to us automatically. So I'm going to say deriving show. And if I reload this, and I go up here, I'm going to rerun my command, and I say item, and now you can see we can actually print this out. So that's very handy. The other interface that's really important when we're dealing with web services is we need to be able to turn things back and forth from JSON. Because that's kind of the lingua franca of the web, right? Like, pretty much everything's going to be talking JSON. Well, we can't directly derive the ability to convert things back and forth to JSON for kind of complicated reasons. But what we can do is we can make something generic. And what that does is that gives us the ability to treat our data type like data itself, so we can actually operate on it with some code. It gives us some reflection sort of capabilities. And so then we can say that I have an instance of ason.toJSON of my to-do item, and an instance of ason. Ason is the JSON library that pretty much everyone uses in Haskell, from JSON of a to-do item. And so now, if we go up, I can say of that to JSON and from JSON.
Would you say instance based on?
Yep, so that's sort of like deriving. It's just a little bit different because we're not deriving it, we are using the default implementation of that interface, which is nuanced. The difference there is nuanced, and it's probably better to cargo cult it for the sake of the talk. Cargo cult it. Just sort of trust that it has to be this way for hand-wavy, complicated reasons.
So is it adding to JSON and from JSON onto the prototype, if you will, for the object? Or?
That sounds like JavaScript words. I don't know what that means.
Yeah, okay, signing a tree.
Yeah. So what it lets me do is I can say now JSON.encode item, and I get back a JSON representation of it.
Initially, I was thinking it was like it was going through like an assignment there, and
Yep. So it's basically giving us an implementation of an interface for free. And deriving does it slightly differently from the way this works. And like I said, there's for that, not really worth diving into for right now. Because what I'd like to do is I'd like to go back over to our server, but before I do, there are a lot of quiet folks for an interactive talk. So anybody have anything else that they think we should do, think we should change, questions?
How do you start the REPL one more time?
So in Emacs, I just use Control-C, Control-L, which is part of Intero, which is an Emacs package. And it will start a REPL and then load the code into the REPL for you. If you're doing it outside of Emacs, you can use Stack REPL, and that will do sort of the same thing.
I might want to have more than one to-do item. Is there like a collection, or is that later in the talk?
Yep, so we do want to do precisely that, right? We want to make a collection of them. But I think that here, these are like our fundamental request types. So I don't think we want to make a whole new type, like a whole new request type for a specific to-do item. We want to move that sort of up into the server level logic. Like the server knows whether we're dealing with a single one or a bunch of them. This is just sort of what the fundamental thing is.
Okay.
What else can I answer about this code before we move on? All right, let's go back over to server. So, oh, I'm sorry, I forgot one thing. Up here, we need to actually make this exported from our module. So I'm going to say to-do item. And we don't need our echo item anymore. So what this open parentheses and these dots are is it's saying export the type and all of its constructors. So in this case, it's saying export to do item the type and also export to do item its constructor, as well as all of these things, because let me actually bring this up. All of these fields are also functions. So for free, I can say give me complete of my item. Oh, sorry, I need to actually make that again. I can say give me complete of my item, and I can see that it's false. I can say give me the title of my item, and I get the title back. I can also say take my item and set the complete status equal to true, and so I can just change a specific field.
So you essentially get getters and setters for free.
Yeah. But it's Haskell, so it's more complicated than that. But so over here on our server now, everything's broken, right? Because we deleted echo, that no longer exists. So my functions can't do anything. So I'm just going to say, all right, let's blow this all away. And let's start with what we think those routes, I think it's a common term for it, should be. So I think the first one that we probably want is new. Makes sense, right? We need to be able to create one. So the next thing that we have is this little like evil-looking smiley face, and this is a type level operator. And what that's doing is it's letting us create a type by putting together fragments of a type. In this case, a route, and then I'm going to give it a request body, and that's saying like what should the body of this request be. Well, the first thing is it needs to be JSON encoded. So I'm going to tell it that it's going to be JSON encoded, and it needs to be a to-do item. And then what type of request is it? So I have a body. It's JSON. Well, I think that it should be a post. And the response to that post is also going to be JSON encoded. And I think what I'm going to give back is an integer, because I'm like, you just sent me the item. You don't really care. You already know what the item is. You gave it to me, so I'm just going to tell you what ID that I assigned to it. Because if we think about it, we don't really want our users being able to tell us what the ID should be, because they don't know what IDs are actually available. So I think we probably want to go back, take this ID out of our request type, because it's not something that we really want the user telling us in our request. So now over here, we can say, we'll get to an update, yep.
So that's not really the definition of it wouldn't be considered like a class. It's more of a contract. The request type that you're defining the data for the to-do item.
It's more like the API is a contract, if you think of it. And yeah, the request, the to-do item is really like what the encoded or decoded values that are in our contract should look like. So we want to make a new item, but we have to tell it, well, what is a new item? A new item's an endpoint, but I need to give it a type. Well, I know that it's going to get a to-do item because that's the body of the request, so I'm automatically going to get the body. And what I'm going to give it back is again, a little bit hand-wavy. It's this apt.io int. And what that means is that I'm running inside of my application, and I'm doing some input and output, and the end result of that is I'm going to give you back an int. And so that's going to be the ID that you're going to actually store. So I might be like normally going out and putting this in a database, or doing whatever I'm going to do, sending a email to your boss telling them, this is what you're working on next or whatever. So I can say undefined, and that's a nice little shortcut because it means that we can compile this and make sure it all works. Now, it would crash if we actually try to run this because undefined is nothing. We can't actually evaluate undefined, but it does let us know that what we expect from our function matches up with the contract that we defined with our API.
Is that similar to the triple question mark in Scala?
I don't know Scala that well, so.
But it's just like a placeholder that allows you to compile.
Yep. So.
One question I've got is, I'm getting an error from the line instance JSON to item from server from request.hs. Just want to make sure that I'm not missing something. All right.
All right. And after we get through this, I'm happy to come take a look over your shoulder too and see if we can figure out what's going on. Okay, so we have this to-do item. So let's actually put it somewhere. So I'm going to do some stuff. So what are we going to do? Well, I don't really want to deal with databases in this talk. So let's just say that we're creating an in-memory representation of this. Let's go back and. So the first thing that I want to do is I want to import this library data. I'm going to qualify it. So data.map.strict is just one of the containers. It gives us a map, sometimes called a dictionary or an associative array, like a million different names for them. In this case, we're calling it a map. So we have a map. What do you think we're going to do? We probably want a map defined somewhere, right? Like, right. So I'm going to say this is a map of integers to do items.
Okay, explain that line there to me.
All right.
Is that defining what goes in the...
Yep. So we're saying it's a map from key type to value type. So a map from int to do item. And empty is hopefully self-explanatory, but if anybody would like me to go into it, I can. All right. Yep, so that's making an empty map. No, it won't compile.
No, you're not allowed to have any uninitialized stuff.
Well, I don't have anything, right? Because I'm defining a function here, but I'm telling it that I'm giving it a map of instance to do items, but if I don't give it one, then how can I compile? It is, you cannot represent an uninitialized value in the language. So I'm going to say that we have, so you all don't know all of the libraries that are available, so I'm going to go a little bit code jazz on everyone for a minute. So I'm going to import a couple of utility libraries that we want. So we want data.maybe and data.list. And I'm going to say, let's make a function that says next ID, and it's going to take a map from int to anything. We don't really care. could be our to-do items, but it can be anything because all we care about are the keys, right? And we're going to give you the next number in the sequence. So I'm going to say items. So the first thing that I'm going to do is I'm going to say, let's let our key values be map.key of our items. So that's just going to give us a list of all of the keys that are inside of our map. Just take off the values, give us back a list. It's going to be an unsorted list because it's not necessarily storing things in any particular order. Or rather, it's storing them in an efficient order for looking up, not necessarily an efficient order for iterating. So we probably want to sort these, and we have a sort function. So I'm going to say sorted keys is sort keys, but that's going to give us a descending sort. So I'm going to reverse that list. Does anybody know why I made a new variable called sorted keys here? Yep. So everything in Haskell is immutable. We have no mutable values of any sort, and we can't ever change any of our values. So we have our sorted keys. So let's say our biggest key is going to be, we're going to use this function called list to maybe of sorted keys. And I'm going to bring up this this REPL again just to show you all what this is. So if I have a function like 1, 2, 3, I can get the first element of it. Actually, let's do 3, 2, 1. Right, this is what we're going to have, some keys like this. And I can get the first element by saying, give me the head of the list. So, because what I really want to do is I want to say, give me the biggest key that we have in the list and then return one more than that. That's going to be the next available key, assuming like threads and, sort of hand wave concurrency away. But I'm starting out with an empty list, and if I try to take the head of an empty list, I get an exception because I can't take the head of an empty list, right? So this is one of the warts of Haskell, is there are a few of these functions here that will actually raise an exception. So we have this nice function called list to maybe, and if I give it an empty list, it says there's nothing back, and if I give it a non-empty list, then I get the first element, and if I give it a series of, I'm just always going to get the first element in that list as long as there is one, and otherwise I'm going to get nothing. We have this other nice function called from maybe, and if I give it some value, I get that value back, but if I don't give it anything, I get a default. So that's pretty handy, right? So we can put those two things together. So I can say, what I actually want is I want to say from maybe 0, because we're going to start with key number 0. So now we've gotten the next available key out of our map. Is everybody following along with what we did there? Yeah, so let is basically a way of saying here are all of the intermediate variables that I'm going to use in some expression. So basically let are a bunch of intermediate variables, and then in is sort of the value that we're returning out of our function.
Is there a reasoning behind naming it from maybe and list to maybe?
Yeah, so list to maybe is taking a list, right, and it's maybe giving you the head of the list, right, because an empty list is equivalent to nothing. And then from maybe is literally you have a maybe and you're converting it from a maybe. Yeah, so I'm giving it a default here, right? So if we tried to give it a string though, we'll actually get an error because it knows that over here we're working with numbers, but we try to give it a default value of a string. But we've told it we're giving it a number back, so that can't ever make sense. So it'll actually give us an error if we do that. It'll only let us give it a number. Unless we told it that we had a list of strings, then it would give us an error unless we gave it a string. It knows what type we're working with, and it'll give you an error if the maybe value doesn't match up with the default. So the naming could be a little better. It makes sense once you've stared at it for 10 years, right? So this is a really, I think, good explanation of how this algorithm works, but it's not the way that we would write it in Haskell. Because Haskell makes it really easy for us to combine separate functions. So we don't actually have to use all of these intermediate values. There's a way that's really common in writing Haskell. It's called point free. And if you think of an intermediate variable as like this code point, right? We want to eliminate all of those sort of intermediate variables, and we want to talk about functions in the mathematical sense and how do we actually compose functions. So you all remember like back in high school algebra when you had like fog, like f composed with g as the output of, you call f on the result of calling g with some value. So like how I have reverse of sort. So we have the same thing in Haskell. It's the dot. That's our function composition operator in Haskell. And it goes from right to left, so you kind of read it backwards. So what we're actually going to be able to do is we can say from maybe of 0 composed with list to maybe. Actually, sorry, we need to take the successor of the output of list to maybe from reverse, from sort, from map.keys. That's how we would write that more or less in Haskell. And we never even have a variable over here on the left-hand side because that's kind of implicit, right? Like map.keys takes something, and then it just goes all the way back through all of this combined pipeline of functions. So I'm going to leave that commented version up there so everyone can read what the heck this thing actually is doing. Yep, so the type of this is still it still takes a value, right? But I can combine functions without ever explicitly having to say that they take a value because the compiler knows that it's a function that takes a value. Hand-wavy magic, don't worry about it. Yeah, so this $sign is basically saying, like, hey, I have this function, and I want to run it on something, and maybe I have one of them, so if I do, apply this function to the value that's there, but otherwise don't crash, just like keep giving me nothing.
So that's a composed function, so you still need another line to call that function with your list.
Yep, we're going to call it.
You just answered my question,
So let's go back down to our app server here. Right, so we have some to-do items, and we have a way to get our next ID. So there's still something missing, and I'm wondering if anybody has picked up on it yet.
the +1
That's the successor is the same as +1.
Okay.
You still haven't defined what undefined is?
We're going to just get rid of undefined eventually. Like, it's just a placeholder. So you remember how I said everything in Haskell is immutable, right? We can't change anything. So we have this to-do items, right? But that's an immutable dictionary. So how are we ever going to get an item into an immutable list, right? Like, we can create a temporary list inside of our function, but then as soon as our function is called, it's going to go away, and we're just going to keep spamming to-do items into this bucket, this evaporating bucket where things are going to just keep going away. So that's kind of a problem, isn't it? So we will do that, but we're also going to bring in this library called control.concurrent, and it's going to give us some synchronization primitives, but it's going to give us this thing called an invar, which is a way to pretend like we have some mutability, even though there's no actual mutability that's happening under the hood. But to make that a little easier, we're also going to import this thing called system.io.unsafe, and we're going to just pull a single function out of it called unsafe perform IO. And what this is doing is this is saying, like, hey, we're working in this pure functional language where there's no such thing as immutability and everything is like makes sense. It's like academically pure, and throw all of that out of the window and just do what I tell you to.
So would you do this in production?
So the pattern that we're using is something that you'll see a lot in production, where we're basically creating some initialized state at the start of the program where, like, we need some resource, and everything that we do after we've acquired it will be pure and following all of the rules. But we just want to make sure that it's like there at the start of our program before we do anything with it, because it simplifies all of the code that comes after it. So we don't technically have to use this. It just makes the code a whole lot nicer, and there's not a whole lot of reason not to in very specific circumstances. So what we're going to do is we're going to say that the type of this now is actually an invar. So it's a mutable map from inst to to-do items. And to create it, we're going to say unsafe perform IO of new invar of a map.empty. But of course, we don't actually write it like this because this makes sense and it's mutable. Instead, in Haskell, we use the equivalent to saying everything after this is wrapped in parentheses. It's kind of a neat trick because it's an operator that does nothing except have precedent. So now we have this mutable variable that we can use. So what we're going to do over here in our app server is we're going to have this thing called a do block. And what a do block is doing is it's saying, like, you can think of it as saying, I want to write some procedural code. Like, all this pure functional stuff is nice, but what I really want to do is get some state and mutate it. So inside of this do block, I'm going to say that I want my to-do list to be, I forgot another import. So I'm going to say that I want to take my to-do items. So this is sort of a combination of a mutex and working with a mutable variable. So what I'm doing is I'm saying there's this shared bucket out here that has my to-do items, and I can change them around, but also make sure that there's a mutex on this so only one thread can actually be touching this at a time. So we have this, but we can't actually use it just like this because of, again, hand wavy reasons. So, sorry, I just realized. I was changing the wrong function. So, yeah, so servant is a concurrent web. Well, servant is using WAI, which is a web application interface, which does handle concurrent connections and all of the nice stuff that you would expect with exponential backoff and all of the stuff that you would want out of a production web server. And what's really interesting is servant is also a client. It's not just a web server, so you can use that API definition to generate client bindings and server bindings from the same piece of code. So we're going to say lift.io of take mvar to do items. And again, don't worry too much about that lift.io because that's sort of a little bit nonsensey. And so we're going to say we have this to-do list. We want our ID to be the next ID of our to-do list. So that's where we're actually passing in that list. And now I'm going to say let to-do list prime is going to be a map.insert of that new ID and the item into to-do list. And then we want to lift.io, put mvar, so this is a function that will actually take a to-do list item, and we're going to talk through it. I'm sure lots of folks have questions about what just happened there. Who wants to start? Yep. So we have this thing in Haskell called IO, which you can see right up here. And this is how we manage doing all of that stuff like input and output and writing to the network and disk. And even doing stuff with mutable variables is really like considered a side effect, right? It's something that has an effect other than just strictly reading the inputs and returning a value from the function. I'm not familiar with C# really, but yeah, so IO wraps like all of our side effects. But what we have here is this, we're not just using IO, we're using an application-specific transformation on top of IO. So what we're doing is we're saying take this like basic IO operation and lift it up into the sort of global like application state that's going to track not just IO, but it's also tracking like error handling and configuration, what port we're running. It's like sort of the bucket that we're throwing all of that like global application stuff into. So that's what Lift is doing, is it's taking like a simple IO call and bringing it up into the context of our application. And you don't need to do this for simpler Haskell applications, and there are a lot of people that don't like this style and don't use it even in big production applications, but it is a common approach that you'll see. So something that might seem really misleading is this return statement here. Because this does not do what anyone, I don't know what you all know, but I suspect that this does not do what very many people suspect that it does. Before I said that, how many people thought that this was returning a value out of the function? Yeah, that's not what it's doing at all. So IO is the most misleading thing in Haskell, or sorry, return is the most misleading thing in Haskell. What return is doing is when we have these arrows here, we're taking things that are doing IO, or doing apt.io in this case. And they have some system effects, and we're basically saying like, hey, I have this thing, this value, but it depends on the system state. It depends on things like having written to disk or having written to the network. I'd really like to work with that value. So what I want to do is I want to go through, do everything that you need to do to be able to give me that value, like send the request, write the file, launch the missiles, whatever. Get me this value, let me work with it, and then when I'm done, I will return it to you, and now it's back in that context of the global application. So I'm really saying like return this value that I've changed around back into that like that IO thing. And it just so
Value has changed, right?
say what?
Value has changed.
Yeah, so specifically in this case, what I say is we have a computation that's taking a global application state and some value, right? In this case, it's our list. It's doing some changes to the application state, which is the mutable variable stuff that it's doing, right? And then it's sort of taking a value and it's saying, like, here's this value. I'm returning it to the context of stuff that's happened in global application state. And so the way that it compiles down is basically I say, like, I have this value ID, and it depends on the fact that something has been executed that gave me access to this global mutable variable, which depends on the fact that something has been like actually created this memory space. And so you have this sense of like this value to be able to work with it, it depends on its previous things having been created. And the reason that we need to do that is because Haskell is a lazy language. So I can actually, let's add up all of the numbers. I'm going to say, anybody watch Numberphile? The sum of all the natural numbers is negative 1/12. So I'm going to add up all of the numbers, all of them. And so Haskell actually, by default, it uses an arbitrary precision integer, so you can you're not bound by machine word size or anything. And that ran really fast, right? Let's do another one. Let's say, yep. So let's say I want to do, so now I'm doubling all of the numbers. That should be even harder, right? And actually, like, what's the, right? Like, what's the 100th double number? And too much doubling, right? Like, I can work with like this list of all of the numbers, and it's fine because it actually is only ever calculating a value that I need. So it's not calculating the sum of all of the numbers. It's just calculating like, here's a computation that depends on the sum of all of the numbers. Or in this case, here's a computation that depends on the 100th element of a computation that doubles all of the numbers. So the only thing that it has to do is calculate, in this case, like what's the 100th number out of all of the numbers, and then double that and give me the value back. Which is great. It saves us from doing a whole lot of work, but it's a real problem when you say something like allocate some memory, and Haskell goes, okay, and it does nothing because you're never actually asking for anything with that memory. So we need to introduce this thing called I/O, which actually introduces a dependency between creating the memory and using the memory in order to make sure that that memory is actually there when we go around and actually try to use it. So that's how, and you'll hear this thing called a monad, and the reason for that is hand wavy, don't worry about it. But when we talk about the I/O monad, what we're really doing is we're talking about this notion of like, I have this sequence of things, and I want to kind of like, every time I do a new one, I want to take that like stuff that's happened in the real world, that I/O stuff, and combine it with like all of the stuff that it needed to get there to that point. And what a do block is doing is it's saying, okay, like everything that's coming in this block has this implicit dependency. One thing depends on the thing before it, depends on the thing before it. So I'm just going to kind of work inside of this context. And return is saying like, okay, here's the final value, here's the final result of what I was trying to do. So here's the value back, and after we get out of this like return, right? Like now we go back to not depending on anything, not having that like explicit dependency, and we can go back to treating everything like just however we want. So another example is if I do let A is going to be print hello. So these two arrows, this is the same as sort of doing two things in a do block. So I'm going to do print hello. Nothing out because I'm never actually evaluating A. I don't need the result of it, so it's not going to do anything. But you can see that as soon as I evaluate it, I get both because I said that that final value depended on the previous value.
On those do blocks, is the indentation?
Yep.
This one is that just
Haskell is an indentation-sensitive language, so. Yeah, so that single tick, that's just a valid variable name character in Haskell. And what we often use it for idiomatically is to represent a slightly modified version of the other thing.
So it's not like, okay, it's just character, there's no special magic going on.
Right.
In the let block there,
Yep.
why aren't we return or why aren't we yielding any values like we were in the last let block we looked at?
In which let?
I don't remember what the keyword was.
referring to N.
What's that?
N, I think, is what
In? Okay.
Oh, okay, right. So the reason is because inside of a do block, let is how we define pure values that don't have any particular dependency. So we're not, because we're inside of that do block, we're not really in an expression. We say let in where an expression follows. And just let inside of a do block when it's just sort of a pure value that's depending on its place in the code. So the way this desugars would be like if we said some like if I did let, or if I did ID is like let it would be it's sort of like just syntactic sugar or something like that approximately. So, and this whole do block thing is just syntactic sugar. You can rewrite it using those same sort of arrows, the bind and the sequence. But this is far more readable in my opinion. So now we have a, yep, go ahead.
So the reason you use to-do list has a different variable name from to-do items?
Because to-do items is a separate thing. To-do items is my mutable store, and to-do list is the value that I've taken out of that mutable store to work with.
So it's not a list.
It's a map, a dictionary. I mean, it is actually literally this map of ints to-do items. We could name it to-do map if you want.
It's essentially a clone of it, a temporary clone of it.
Yeah, so yeah, it's basically the result of looking in that bucket and figuring out whatever happens to be there.
We turn it into a JSON object, right?
So we don't have to. Servant will do that for us because we've told Servant that the result of this post is something that we will get that is in JSON, and it should be a to-do item. And so Servant is going to say, oh, I have that from JSON instance that we defined earlier, and I got some JSON, so I'm going to try to decode it. And if I can't, then I'm going to know enough to send back a bad request to the client. Should we do it? Should we watch it run, or should we write a lookup function first so that we can make sure that it actually did what it wanted? We're running kind of late, so
Until it runs, you can race.
all right.
Unless that's gonna take a long time.
So we can do stack run. All right. So let's so let's post to this is run 80. And it has to be actually give me a bad request error if I don't set the application or the content type. So we said title, hello, and the here are just the names of the fields in our type. So description, world,
And in this particular instance, not correct.
correct. And if we run this,
Is that what you mean by optional?
Well, an optional parameter you could omit, but
Like if you don't have world for description, it would send an error as opposed to sending
Yeah.
an empty description.
yep.
correct.
We actually need to point it at new. That would help because I got a 404. And you can see we get back 0 because that's the ID that it gave us. If we run it again, we get back 1, 2, 3, 4.
Is this some Emacs magic on
Yeah, this is Rust client mode. So yeah, we wrote the world's worst to-do list application in only like 2 hours.
You said hello world, that's the important part.
So you said that based on the fact that to-do item inherits the to JSON from JSON,
Yep.
would we have to then define something for the collection to return back all
Nope.
4 of those?
Because for things like map, they just part of part of that library is if it's a map of things that can be serialized, then you can serialize the thing.
And it automatically turns it into an object or
Yep.
or JSON or any of
Yep. Yep, exactly.
It could be either one. You can make the JSON.
Yeah, out of a list, out of a map. ASON is a really widely used library, so most containers, if there's any sensible JSON representation, will provide their own instances. So what you can do is you can say like, I'm a list, right? You can say a list can provide an instance so long as the thing in the list has an instance. So you can depend on the instance of the thing that's inside of your container.
It seems unique to Haskell. I'm kind of new.
Yeah, you can do it in Rust.
Line 483,
Yep.
is that item coming from the?
This is the parameter to our function. So what servant's going to do is it's going to see that, our contract up here said that the body should be a to-do item. So it's going to pass that body in as a parameter to our function. So it will handle deserializing and validating our value, and then just give us that deserialized validated value. So like if we changed this to say that we wanted to get an int, then down here we would get an int. And if we do, if we defined another endpoint, and we won't implement this, but we can say lookup, or actually let's do modify. We can say that takes a query param that is required, and its ID, and its type is an int. And then it also takes a request body that should be JSON encoded, and should be a bool, and it's going to be a post request, and its output is going to be JSON, and it's going to return a to-do item. And so if we'll just call that foo, right? So the type of this would then be an int, because that's our first parameter that we've defined as part of our API contract. And that's going to come out of the query parameter. And the second is going to be a bool, because that's coming out of the request body. And that was the second thing that I put up here in our contract. And then the return type is going to be an apt to-do item, because that's what we're saying the response will be from the response that we're sending back is going to be a JSON encoded to-do item. And the order of these parameters is dependent on how we define it in the API specification.
What's what do we do with the stick in his mouth next to modify?
Yep, so that's just how we define multiple routes. So we're just sticking them together with that ugly thing. And we use the same operator here to combine our different functions that are actually implementing them, and they have to be in the same order. What else can I answer about all of this nonsense?
So I was going to ask just a more general question about Haskell in the larger language environment. What are some reasons why I would choose to use Haskell for tools like this as opposed to other options? Like what are some of the big benefits of Haskell?
Yeah, so I think probably the biggest benefit that people would give you is that as you are working in a larger code base, continuing to maintain that code base, refactoring it, and working on it without introducing regressions becomes much easier, because the type system is going to automatically catch a very large class of errors that could get introduced without the type system. The library ecosystem is pretty good, depending on what you're doing, obviously. Performance is pretty good. In most cases, the RAM usage is a little high, but response time and CPU utilization is generally pretty good.
When you compile this, it says compiling library, whatever. Does that eventually get vendored into one binary?
So the way that it depends on what build system you're using. So the way that it works in Stack is we're using some LTS release, and that defines the versions of all of the packages. So as long as I say I'm using LTS 13.21, that implicitly means that I'm getting this version of this package and this version of that package, and so on. If we were using Cabal, we could pin it to a specific hash or a specific version number. So if we look at our...
So is the executable a single executable?
Yep.
No runtime?
No, it has shared libraries for C dependencies. Most of your Haskell dependencies will get built in. But
Built into the single executable?
Yeah.
So you can give it to somebody on a machine that doesn't have Haskell installed?
Yeah, it's not like Go where you get a completely self-contained binary, because you're going to depend on libc and libgmp and a couple of other native libraries. But yeah, it is an application that you can give somebody. They don't need a Haskell environment to run it.
And you said it's GC, right? So it's not interpreter based, right?
Correct.
So the GC is part of the binary?
Yep. Yeah, there's not a VM or anything either. It's just running native code. Although you can compile to JavaScript.
So
Yeah, so I mean, if you're talking like modern cloud infrastructure, right? Like you throw it in, some sort of, maybe it's running in a Docker container, or it's running behind some scheduler, and you have an ingress controller, and it's load balancing across a bunch of instances of the application. And
Is Elm built on top of this?
Elm is written in Haskell, but it's other than being written in Haskell and sharing some syntax. It's not. I mean, they're separate languages. There are some libraries that make it easy for you to generate like Elm data types from your Haskell data types. I mean, it's just somebody wrote the libraries to do it. Other than that, there's no particular like special integration, I guess. How many people feel like they know less about Haskell than they did before we started this this talk? All right, that's good. How many of you like Haskell less than you did before we started this talk? All right, only one, so that's pretty good.
It's interesting, but I feel like about 9 years this stuff was handled.
I think the thing that I was really hoping for people to see out of this talk was more the idea behind using types to define the contract of an API, and how having a tool like the Haskell compiler that can understand types and really enforce that let us take a very particular approach to how we implemented our API. Because you notice we started with our data type definitions, right? Like, what does this data look like that we want to deal with? How do we want to represent the way that we interact with it? And then we let the compiler guide us by giving us error messages and things like that. It told us like what we needed to implement and how we needed to write it. And I think that approach to writing programs is different from the way that I see people working in a lot of other languages. So I think teaching Haskell in an hour or two is just not going to happen. And rather than getting lost in the weeds, I thought it was better to focus on sort of where you can get if you were interested in spending the time to learn everything that would need to get you there.
I'm sorry, and I didn't mean that to come across as a criticism. I just mean there's a lot to it that you're really going to have to. It seems like it's different enough from everything else I've ever done that you really have to make a commitment to sit down and go through it or whatever.
Yeah, I think that that's true. Haskell in particular has a very gnarly learning curve where if you start with the tutorials and things, right, you can get to a certain point very easily. Because the basic syntax is really nice, it's very lightweight, things make a lot of sense. You'll go through one of the introductory books and you're like, this is really good, and now I want to do something bigger with it. I want a real application, and you fall down a canyon, and luckily you're cushioned on the pile of dead bodies of people that came before you, and you start trying to climb your way out. And there's just this like horrible gap. And then at some point, if you persevere and you really like learn the language that you need to, not Haskell the language, but the jargon and all of the ideas that people sort of bandy about casually when they're talking about Haskell. If you make it to that other side, then you're equipped with this view of how to write programs that is very powerful. And then you go around telling everybody that they should use Haskell, but you've forgotten like how hard it was to get there, and so you completely underestimate the learning curve.
So what range is your book? Is that for beginners or?
I am specifically targeting people who have fallen down that like gap, right? So I want to be the second Haskell book that people read after they read one or started to read one and then realized that they didn't know how to really write a full application.
How do you feel about the Haskell wiki books?
Yeah, so I think that those can be very good. The issue there is they explain a lot of concepts in isolation. I don't think they provide the set dressing that's really necessary for people to understand when and why you would use some of the things that they're explaining.
So I apologize, I came a little late. Did you say you're writing a book or you have written a book?
Am writing.
Oh, cool.
Do you have a title or anything?
Not yet.
Okay.
To be titled forthcoming Haskell book.
Finding out the Haskell pattern.
So would you recommend starting with the Haskell pages like that?
Yeah, I think it's an okay place to start. There are a couple of other good books that are out there, and I apologize. There have been some really good, or there have been some books that have been released that I've heard are very good. I have intentionally not read them because in the middle of writing a book, I don't want to accidentally plagiarize from somebody else because they had a really good way of explaining something. So I have purposely avoided reading some of the new books that have come out in the last year or so. But if you go look, there are a couple of newer ones that I've heard are very good.
Do you think would this be a bad first back-end language to start with? Do you think this is a hammer? You know what I mean?
Yeah, so it depends on what your goal is, right? Like if you want to understand computer science very well, Haskell is a great language to start with. If you want to get a job, Haskell is a terrible language to start with. I think that there are people whose cognitive model of computation fit better with functional languages. And so I think that people that maybe are setting down to work with something like JavaScript, right, or Ruby or Python or Go, and they really are having a hard time getting it, I suspect that some of those people, if you put them in front of a functional language, they would do much better. And I think Haskell has some benefits in terms of being a first functional language, but that like gap, right, is a big drawback too. So I would say if somebody was like, I want to learn Haskell, I don't know any programming, the first thing I would say is, do you want to get a job? Because if that's your goal, don't learn Haskell. And if they say like, no, I'm independently wealthy and I would like to learn Haskell while I'm floating around on my blimp, then I would say like, do you have a support system of people that can help you? Because it's a very challenging language to get started with alone, and there aren't really like, there are no boot camps that are teaching Haskell.
You can find the answer to JavaScript question anyway.
Right. So, and you can find the answer for a lot of Haskell questions too. You just need like a master's degree in math to understand the answer. So yeah, I think overall the answer to your question is no. It's probably not a good first or second or third language for most people to learn on the back end.
Are you currently working in Haskell?
Yeah.
Not in St. Louis.
Not in St. Louis. Well, I'm in St. Louis.
Right.
But you work remote.
Yeah.
Just clarifying that, yeah. She had to broaden her horizons in order to work in the language.
That she wanted to work in.
Yeah.
Well, I would say that the code seems to naturally be clean,
Mm-hmm.
and I really like the types. And also, I think I like the part where you have the maybe or option or whatever it is, so that when you compile, you can't end up having like some branch that you didn't go down in testing. Like the compiler, is that correct? It won't let you like have a branch that's because you've got to declare the types, right?
Yeah, so you can have what we call, in Haskell, we call them partial functions. So it's a function that only partially handles its specified input domain. So you can write a function that says, I'm going to take a maybe, but I'm only ever considering that I'm getting a just value and I'll crash otherwise. What you can't do is you can't say I'm giving you a value, but then I actually don't give you a value, right? So, and you can tune the compiler to warn you if you're missing like a case statement or have like some other case where you're not handling everything. But you can write those if you're determined to.
Yeah, but like in other languages, you don't find out that you didn't notice that until it's in production.
Right. Yeah, you make a conscious choice to not handle things.
And I really don't yet know any functional language, but I've been trying to study about it. And I have to say that now, and I've not written anything at all useful in a functional language, but still in my regular work using different languages, I can't like unlearn the stuff that I learned from the functional part. So now I'm doing stuff that I used to do, but now I have to change it because I realize that it's sinful. Right? You know what I mean? Like with the purity and side effects and all that.
Yeah. Yeah, I think that, one of the things about Haskell as being a pure language, the compiler is aware of that, right? So there are a lot of heuristics and hacks and things that make pure code efficient. And certainly if you're writing that same style of code in some other language, you're going to take a really big performance penalty, as well as possibly make all of your coworkers very angry. I think that languages like Haskell really do help you think differently about the way that you approach code. But I have found that there's often a temptation to write Haskell in any language. And it usually ends up being a bad idea.
Because of like tail call optimization.
Well, and just, you don't want to be fighting against the idioms of the language that you're using. Because if you really want to use Haskell that bad, just use Haskell. And if you're not using Haskell, like, write your code in a way that it's going to actually fit with everything else in the language that you're writing.
It reminds me of everybody trying to mimic Ruby on Rails. Outside of Ruby, which Ruby had all the niceties that made Rails work the way it worked.
Right.
Which didn't like frameworks like PHP or languages like PHP that a lot of people
Right.
try to mimic Rails and
COBOL and cogs, etc. Yeah, and I see the same thing in the JavaScript world. I see a lot of people talking about functional JavaScript, and I think that there's some of that code that I've seen that's good and makes a lot of sense, but I see a lot of stuff where it really feels unnatural because it feels like you're trying to graft one language onto another language. And I really question, at the end of the day, how much of that is actually beneficial to writing production code and how much of it is sort of navel-gazing by people that would like to be doing a different job than the one they have. Any more hot takes that I can offer?
Are you familiar with Elixir enough to be able to compare them at all? Like, is there?
I've used Erlang. I've never actually used Elixir.
I like the syntax of Elixir a lot. I've looked into that one a little bit. I haven't done projects in it, but they seem sort of in the same space. I'm curious. If you were able to how you're give a comparison.
Yeah, I would say, not knowing Elixir, but speaking of Erlang, and assuming that they're roughly comparable enough that what I'm about to say is applicable, right? The pure functional part of it is definitely, a thing that you get with Haskell, but I think that Haskell's type system is something that is, I think the type system is the dominating factor in how you approach writing code in Haskell. So I would say that there's a lot of things that make sense in Haskell that you wouldn't really do in another pure language that's untyped, just because you don't have some of the same capabilities that you would have with Haskell's type system.
Or how many people got their PhD just talking about something about type systems?
A lot of people. There's an ongoing joke that Haskell is the best documented language that's out there because every single library was somebody's PhD thesis.